Hello everyone, I'm Anjali Shukla. Welcome to PG Cloud Security. Let's get started. So we have two important concepts, namespace and cgroup. Namespace limits what you can see and cgroup limits how much you can see. So let's start with first, which is namespace. So namespace is a Linux feature that we are discussing about, and it ensures that processes in one space are independent and invisible to other processes. It means if I have two containers, both namespaces, processes are isolated to each other, and it provides isolation, creating a self-container environment for processes, and that is a core part of containerization. So if I take a real world example, let's say we have a hotel with multiple rooms. Each room has its own key, furniture, and guest. Guest in one room cannot directly go into the other room. Okay. So similarly, we have namespaces and we call them a container rooms. So we have a different kind of a namespaces that we were discussing in our last video as well. We have a PID namespace, network namespace, mount, and user namespace. So PID means it will isolate the processes of containers with respect to the host system. So like PID 1 can be for one process, there can be a PID 1 inside the container, but can have 29456 PID inside the host machine. So that's how the segregation or the isolation takes place. Next, we have a network namespace. So each container have its own IP, but yeah, it depends how you have set the network. Like Docker networking is also a very broad concept where we have a different kind of a network. Like we have a bridge, host, and a different kind of a network. So it depends how you set the network. By default, it's a bridge. Container might have a private IP 192.168, while the host is using a 10.0.0 series. So it will be have a different IP at host. Mount. So mount, it provides the isolation with respect to the file system. Let's say I have mounted the /app directory, which is present at my host machine, to the /home inside my container. So for container, /home is entire /app directory at my host machine. But for my host machine, it's just another directory present in my home or a user directory. Next, we have a user namespace. So our root user present at host will be different from the root user present inside my container. The inside container, it might be a root user, but on a host machine, it will be a normal regular user. So next we have a C group, which is very important, the one I discussed about the attack part. So why it is important to restrict that part? Because if there is an attack, one container will exhaust all the resources, and by resources I mean CPU, memory, network, storage, etc. of that server. So other containers or other processes running on the same server will get impacted. So by definition, these are just another Linux feature that we used for the resource allocations and limit the process resources. And they are used to restrict the resources. So real world example, think of it like a gym in your society, and each house gets their time slot and a limited machine so that one tenant cannot exhaust all the resources. So we can restrict memory, CPU, processes, storage, networks, etc. We'll have a lab where we will see how we can restrict the CPU and memory or PIDs using cgroup. So now I think we are clear that namespace provides the isolation, the resource access or resource control is done by the cgroups. So let's jump onto our lab. These are the namespace for my current process, and now I will run a container with Alpine image, and we'll do a exec inside it and check the processes running inside that container. So let me run this command and check the processes. So inside my container, I have two processes running. One is sh, as this is first instruction I gave it to my container. So this will get the PID 1. And the second ps-ef, that is this command that I ran just now. So now we will run this command to get the process ID for the processes running inside my container, and then we will list the namespace ID for all the processes. So first of all, I will exit from this container, clear my terminal and run this. So docker ps-q is the command that we use to get the container IDs for all the containers. So I have only one container running, so I did not provide any filter here. I'm fetching the container ID and storing in container underscore ID variable, and then getting its PID on my host machine, and then running the ls-l to get the namespace IDs for those processes. So now I have these PIDs which are different from the PIDs for my existing shell process. So let's see how we share the namespace between host and container. Let's say I have a requirement, and sometimes there is a requirement especially for monitoring solutions to collect the telemetry, that I have to share some resources with my container to get the data, to get the events from it. It is just an example. Okay. So let's see how to share the PID. So I have to list all the processes running at my host machine from my container. Okay. So that's how you do it, or that's how you share the processes. So here I am running this container and I'm using this flag -hyphen PID is equals to host, running this container with Alpine image and sh. So if I will run ps-ax command here to list all the processes, I will have an entire list for the processes running on my host operating system. Can you notice? I have all these processes running on my host operating system that I am able to list from my container because of this flag that I have used, hyphen PID is equals to host. So I'm binding the processes of my host machine with my container. That was for the namespace part. Now let's see for the C group. So how to limit the resources using C group. So here I am limiting the PIDs, number of processes I'm limiting, and along with that I'm running these commands. So let's see if I'm able to successfully execute this or not. Exiting from the container. So it is saying resource temporarily unavailable because of the limit that I have set here. It is not allowing me to launch a container. So that's how you can set the limit for the PIDs, or the number of processes running inside the container. Next, we'll see how to restrict the memory and CPU. So here I'm using a flag -hyphen memory is equals to 256 MB and the CPU 0.5. Let me copy it. So here I'm not getting any output because I'm sending this yes into /dev null to check that whether this container is actually have restricted CPU and memory. I will open a new terminal. I will run docker stats command to see what is the CPU and memory utilization in my containers. Okay. And if you will notice, it has a limit 256 MB that I have set earlier. And the CPU, it is not going above 50%. So it depends. I have set 0.5 core and the limit. So that's how you can restrict your CPU and memory to prevent the resource exhaustion at the time of attack. So this was it in this video. We have seen how Docker is leveraging namespace and C groups to provide isolation and the resource control. So stay connected with us for next videos and do subscribe our channel. Thank you.